Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on analytical dynamics or classical mechanics, chapter Equations of Hamilton, lecture number 4, in which I will solve some problems on equations of Hamilton. Now we solve a problem. Problem is apply Hamilton's canonical equation of motion to discuss the motion of a particle in a central force field, or deduce Hamilton's canonical equations for the motion of a particle in a central force field when total energy is H equal to T plus V. V is the function of R, where T equal to half m R dot square plus R square theta dot square. Now we solve this. Since we know that in the case of central force field, the force is always directed towards a center and potential energy V is truly the function of coordinates, and hence the system is conservative. When potential energy is a fully function of the coordinates and forces are derivable from the potential function, then this system is known as conservative system. In such a system, Hamiltonian is the total energy, as the motion is always in a plane. In central force field, the motion is always in a plane. So we consider the coordinates r and theta only. Therefore, radial velocity Vr equal to r dot and transverse velocity will be r theta dot. Resultant velocity square equal to Vr square plus V theta square. This is equal to r dot square plus r square theta dot square. Therefore, kinetic energy will be half m velocity square, means r dot square plus r square theta dot square. M be the mass of the body. This kinetic energy is denoted by T. Let this is number 1. Since potential energy V is the function of R given, this is number 2. Therefore, Lagrangian function L equal to T minus V, and this is equal to half m r dot square plus r square theta dot square minus Vr. Let this is number 3. Let Pr and P theta be the momentum with respect to r and theta. Therefore PR equal to partial derivative of L with respect to r dot, and this will be equal to half m multiply 2r dot, means m r dot implies that r dot equal to PR by m. Let this is number 4. P theta equal to partial derivative of L with respect to theta dot. Here half m multiply r square multiply 2 theta dot. This equal to r square theta dot. Here m r square theta dot implies that theta dot equal to p theta by m r square. This is number 5. Let H be the Hamiltonian of the system, and since the system is conservative, therefore H equal to kinetic energy plus potential energy. This equal to T plus V. T is half m r dot square plus r square theta dot square plus V is the function of r, and this will be equal to half m r dot square, means here PR by m whole square plus half m r square theta dot square, means p theta by m r square whole square plus VR. V is the function of r, and this will be equal to half m square, means only remains 1m in denominator, PR square by m plus here also same 1m remains in denominator, and here r square, here r to the power 4, so remains p theta square by m r square plus VR. We may write this PR square by 2m, here p theta square by 2m r square plus V is the function of r. Let this is number 6. Applying Hamilton's canonical equation, we get PR dot, means dPr by dt equal to minus partial derivative of H with respect to R. This equal to minus partial derivative with respect to R. H is PR square by 2m plus p theta square by 2m r square plus V, potential energy, the function of R. This equal to, here we have no R, here we have R square in denominator. So we differentiate this, minus P theta square by 2m multiply minus 2n into R n minus 1 minus dv by dr. Here we have used the total derivative because v is function of single independent variable r only. So no need to use the partial derivative. Since v is the function of single variable r only, this is equal to minus minus plus p theta square 2 cancel m r cube minus dv by dr. This is number 7. P theta dot equal to minus partial derivative of h with respect to theta minus partial derivative with respect to theta. Here h is p r square by 2m plus p theta square by 2m r square plus v is the function of r, and this will be 0 because we have no terms containing theta. This is number 8. Now r dot equal to partial derivative of h with respect to pr. Here partial derivative with respect to pr, h is pr square by 2m plus p theta square by 2m r square plus v is the function of r. Here we get here pr, so this is 2pr by 2m, other terms 0. This means this is pr by m. This is number 9. Theta dot equal to partial derivative of h with respect to p theta. Partial derivative with respect to p theta, pr square by 2m plus p theta square by 2m r square plus v is the function of r, potential energy, implies that theta dot equal to, here we have p theta square, so we get 2p theta by 2m r square. This equal to p theta by m r square. This is number 10. Equations 7, 8, 9 and 10 are results of Hamilton's canonical equation. From 9, r dot equal to PR by M implies that we take again derivative r double dot equal to PR dot by M. PR dot here, PR dot is P theta square by M R cube minus dV by dr. This is PR dot, and we have by M, 1 by M. We take M R double dot. So M, this M cancel, P theta square by M R cube minus dV by dr. Let this is number 11. Since in conservative system forces are derivable from potential function, therefore minus dV by dr equal to FR, force. Let this is number 12. Since from 5 theta dot equal to P theta by M R square implies that P theta equal to M R square theta dot. This is number 13. Now P theta square by M R cube equal to P theta square means M R square theta dot whole square by M R cube. This is equal to M square R to the power 4 theta dot square by M R cube. This is equal to M R theta dot square. This equal to M R theta dot whole square we take here. Here R. Here R square and here R. 1 R cancel, here 1 R remains. And this will be equal to M R theta dot equal to V theta square by R. Let this is number 14. This V theta is transverse velocity. Transverse velocity is R theta dot. Therefore, using 12 and 14 in 11 we get M R double dot here. Here P theta square by M R cube. This is M V theta square by R, and minus dV by dr is FR. This is M V theta square by R is the centrifugal force. Let this is number 15. Here equation 15 is exactly the same form as that of an equation of motion in one dimension for a particle subject to actual force Fr plus a centrifugal force mv theta square by r. Since in central force field of motion the whole force is always along the radius vector, so the term mv theta square by r is termed as fictitious force. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.